Lawson's not here today, so somebody's got to pick up that role of asking questions and say, I know another way to do that same thing. So let me go up on the stage and let's get started. And we'll just play around a little bit here. So, first thing I want to do is to start off in spindle work.
Sorry about that.
And in order to make this as easy for myself as possible, I decided to work with mahogany because it turns nice and I can fake the cleaning on this stuff really easy. Oh yeah, there's another 600 grit. Okay, so this is just a blank. And the first thing we start off with is roughing out. Make sure it's nice and snug, locked, to rest. Now when we start out roughing out, generally, I don't know what cameras you're seeing here, but this is the kind of tool we end up using a lot. I asked Pete to bring me his P&N roughing gouge. Now this actually has a name that is very specific. This is a spindle roughing gouge. And if you look at the catalogs, they are called spindle roughing gouges for a very specific reason. You apply one of these tools to a bowl, and you run into a turning situation where I'm cutting along just fine, and then I end up with this end grain coming around, grabs it. When I was in the retail business, I had people bringing in spindle roughing gouges frequently with broken tangs right here. They're broken because this thing grabbed, the tool is less strong than they were, snaps right there. Those are stamped, the ones you get from Sorbia. They actually go to the machine and stamp those things out, so the tang is very small. This from P&N is actually milled out of a solid piece of steel. I think some of the other American-made tools are also milled out. I could rough out with this thing, but I'm not going to. I will use it. So let's get this thing around. Oh, what do I do to rough out? I use my roughing gouge. Don't like the position. I want a little overhang here so I can not kill myself by running off the end of the tool rest. So just rough it out real quick. I can hear the sound change, so I know I'm around. It's not buffeting anymore. That's why I don't want to call this a bowl gouge. This is just a deep fluted gouge, and for me, this is the easiest way to rough something out, is just to take my deep fluted gouge. Seconds.
Jim, question.
Please.
So you're using the bowl gouge to do.
I'm using a deep fluted gouge, yes.
To rough it out, but I noticed that your technique is different than you normally do. You had it over on the side.
Oh, interesting point. Okay, so let's see what we have on the camera here. You look on the one on your I'm not coming in here on the tip of the tool, but I am using more of the side of the tool. Over here. Now, if you look at that portion, I mean, you can't quite see it. Oh, that's pretty good. What's touching the wood right now looks a lot to the wood like a spindle roughing gouge would look like at the same point in time. What I've got is a longer handle. I've got something here that I can hang down nice. But this piece of metal touching that piece of wood is going to look to the wood very much like that spindle roughing gouge looks.
So what's the advantage?
I think this is stiffer. You saw how I locked it to my side. I was able to do this pretty easily. With the standard sorbet type rough-and gouge, we've got a shorter handle. It is very prone to being neat. Let me say that over again. Coffee a little lacking this morning. I need to keep this square, the wood. So if I cock it a little bit to one side or the other, one or the other wing is going to want to dig in, and it tends to want to pull the tool in one particular direction, and I've got to fight back. So I've got to very carefully keep this tool at 90 degrees to the surface of the wood. So it's a little bit more sensitive to that. That's what we teach in 101, right? Do this. One of the things we find in 101 is the moment the student gets the handle too high, the two wings tend to want to bite in and act like two ice skates going there. And if I slightly move to the left, this thing's going to want to spin off this direction. So I find this is more sensitive to positioning and management. Also, the shorter handle works okay. Now, what I'd like to do next, oh, by the way, on some YouTube videos, you see people coming in here with their spindle roughing gouge at an angle and roughing out like this. Can you do that? You think, effectively? Absolutely. There's no reason why you can't do that. However, rather than using this sorbet,
Jim?
yes,
I'm sorry, are you doing more like a shear cut with that gouge?
you're getting right there to where I'm going next, because that's exactly what I'm going to do to clean this surface up. If we look at the sorbet on the left, down the flute, you see that represents about 1/3 of a circle. And if you look at the P and N, it's a deep U shape. In other words, on the P and N, we actually have two sides that come vertical. So if I would like to do a shear cut here to clean this surface up really nicely, and I use the sorbet, let's see if I can do it. I can. I don't know if you can see it, but from my eye, oh yeah, it shows up on the monitors nicely. We've got a nice clean spot in here. But I'm working on this little portion of the tool right here, vertical. And that's a pretty small area. So if I had this nice P&N, or some of the other ones, D-Way or Thompson or Carter, they have these tall edges. It gives me a larger surface to make this look more like a skew chisel to the wood. Many of us are not really good with our skew chisel, but I can give you that same shearing cut with one of these tools. Nice. And I can really smooth that up very nicely by using the long edge of this thing presented at a shearing or oblique angle. And it cuts really, really nice. So, one way to clean up your surface. How else can we clean up the surface? Well, I always plane it. Anybody ever use a block plane on a piece of wood? Good for you guys.
Not while it's turning.
How many times do you want to make a spindle a certain length and you want it absolutely straight? Well, our tools tend to go up and down. This is going to keep it straight, because it's going to cause you to want to plane that thing straight. I'm not available for lunch today. And I'm doing the same thing I would do if I was working in a flat project. For all of us Woodturners need to know is that the plane iron's got to be set at the right depth. It needs to be set square, it needs to be sharp. And I took it apart yesterday and cleaned up the frog, cleaned up the iron, sharpened it again, tried to set the depth just right. You don't want it very deep. This thing will grab on you if it's set too deep, so be careful. Yes?
When you were doing the spindle gouge, it looked like you were doing it backwards, leading with the bevel instead of leading with the cutting edge. I was thinking I would emphasize any bumps versus like with a plane or a jointer, you always lead with the blade and whatnot.
With this, you said I was working backwards.
No, with the.
The plane?
Spindle.
Still roughing guys, hunting
For
guys.
the SRG, okay. Where'd it go?
One in the rack.
It looks sort of like this. We'll use this one, okay. So you're thinking I might have gone backwards. Well, actually, I need to get this cut going. Let's start here. Now, when I go backwards, I'm going to pull away from the wood and come back. One of the things I want to do is not change my body posture any more than I absolutely need to. If I can keep my hand and my body in the same position, finding the cut again is going to be much easier than if I have moved away and have to reestablish everything. Is that, am I dealing with your question?
No,
Okay. Ask it with different words.
I would go the opposite direction.
You're traveling in the direction of the closed flute, not the open flute.
So if I try to go this way,
No.
nothing happens.
No. Oh, wow.
You got to cut towards the edge.
English
You got to always, one of our goals is always trying to move the tools in the direction of the flute. So if I want to go this way, I'm going to aim the flute this way. If I want to go
Yes.
that way, I would do that.
I think
Yeah, but the angle of the tool,
You can't see
the way
it
you're
from
doing
anymore.
it, you should be going from your left to your right, in my opinion.
I am. From my left to my right. which
Oh. what I-
Opposite looks backwards, Steve.
Maybe.
Come up here and stand behind it, won't you? No, I mean, really.
what's missing there, Jim, is you can't really see what part of the tool edge you are using. So from out here, all of that's hidden.
Touching right here. And this portion from the center over here is totally away from the wood. So I'm just touching right in this point right here. So if I want to go to the left, now I can use the sharp portion
Oh, okay.
and go the other direction.
Hi. That looks good.
Camera over here is the best view. Okay, I made all sorts of messes with this thing. Let me clean it up a little bit here. How's the fastest way? Oh, yeah. Sure. Can I make it smooth with this? Almost as smooth, but not. This is shining, this is not, but the slower I move with the tool, the better the surface got. Going back and forth, it's not going to create a great surface. But that's reasonable. I want to make it smoother. I'm making a baseball bat, and I want to find some way to get this thing nice and smooth. Got to figure out a way to do that.
Jim?
Oh. I don't know if you've ever done that before. But there's no reason you can't use a random orbital sander on a long spindle. And if you're doing long, slender spindles, Kathy, this is one way to get it down from being really small to really, really small. But remember, if it gets small, get your finger behind here to give it some mechanical support. You could actually flex and break something that's really too small. But if you really want to taper something, and you're not good with your tools yet, consider a random orbital sander as one option here. 80 grit, 120 grit, you can remove a lot of wood. Yeah.
More of a comment on your plane, when you skewed it, you effectively reduced the bevel angle.
And I suppose you kind of do the same thing with blade too.
I am maintaining, can you still hear me okay with this? I want to get away from my mouth because there's a lot of popping otherwise. I'm still using the same bevel, and the angle of the tool relative to the wood stays constant, but I'm skewing the angle. Instead of going in like this, I've tilted it like that.
And like the plane, that reduces effective bevel angle.
Okay, if that's what you mean, yeah, then it does, yeah, right. So one thing on my block plane, had I gone in with it like this, it would have been a better plane cut. In fact, really nice chips. So smoothing things down, that's one way. How many of you use your skew chisel? Good guys, good gals, I appreciate that. There's basically two different styles. One has a straight edge, one has a radius edge. And while we have both of them in the classroom, the radius edge is primarily used for cleaning up surfaces like this where we really want to plane down a long distance. And the reason the curved edge is used, it brings these 2 points back further away from the wood surface and gives you more control. The chance of running this into the wood is reduced some. Planing. Now that chopping at the bottom at the very end there is pretty deep cut, and the pulling stuff away. Oh, that's, from your point of view, that's about 600 grit, right?
Start at 600.
Start at 600. Yeah. So, but the key in using the skew chisel has always been a problem for many of our beginning students. We've got to get it on the tool rest. We've got to get the portion of the tool we call the bevel against the wood at the same time. And then to raise the handle, to get that cut start, is basically twisting the tool just a little bit. So, against the tool rest, against the wood, and I'm going to rotate the tool to the left. My thumb is making sure they both stay in contact. I rotate, 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 and I find some dust come up someplace. There. And at that point, I want to freeze. And I want to move my whole body. The difficulty has always been for me that the process of breathing is enough that it moves and changes the tool angle. So you find me not talking while I'm doing this thing because I'm holding my breath. And I also lock it into my side. And if I got this locked in a nice triangle here, all I got to do now is move my body. And I can step away, I can come back and almost get that back to almost the right same position again. We talk about raising the tool rest, and the reason we raise it is so the tool is up here where it's comfortable and where I can see what's going on. I could have done it down there, but my tool would have been at some weird angle and it would have been difficult to manage. So we raise it up here so I can work at about 10 or 11 o'clock. This is a clock face.
Are you above center, Jim?
Yes.
Way above center. Way above center. I'm about, imagine this is the clock face. I'm someplace between 10 and 11 o'clock on that clock face. Because it puts me in a place where it's comfortable for me to stand here and do that. So here's a straight edge one. Do the same thing. In fact, I can do better with this one than with the other one. The reason is, I use this more. And because I use this tool more, I'm more familiar with it, I'm more comfortable. You pick up a tool, specifically skew chisels, that you haven't used. You take it out of one of our cabinets or somebody loans you theirs. There's a thing that this is a tool you don't know yet. So you'll have to practice with it for a little while. This one I use a lot. So at home where I need something, I grab this tool because I know the tool. And right now I've felt more comfortable making this cut. Actually, I can see the surface is actually better than with this one. Both of them have been sharpened and both are holding a really good edge. So it wasn't the tool, it was me And in fact, I felt better with this one.
Jim, how about flat versus oval profile?
Say again, I didn't hear.
Flat like you have there versus the oval profile.
Oh, I don't ever use an oval skew. And that's a good question, and the reason I do not, the oval skews, I can never lay it flat anywhere, because it's literally shaped like this. As we come out towards the edge, double bevel like this, it gets thinner. As we come out towards the edge of the tool mechanically this way, it's also getting thinner because it's oval shaped. So when I get out to these points on either end, it has so little mass behind it that I find them unsteady. I find they vibrate. I don't like them. And I've never been comfortable using it. Now, other people say, well, I've got one that works just fine for me, that's great. But for me, they have not been something I've been working very well with. When you go to the sharpening platform, because I sharpen these by hand, I lay them on the platform and I do what I have to do. The oval skew is not going to lay on the platform, so I'm going to have to make a fixture to keep that dead flat. Or I'm going to have to be really good at holding it at one single point on that curved edge. So I find it difficult to sharpen. I find them as less steady when I approach either of these cuts. Are there value for them? Because that point is so small, you want to get into a super fine detail. It's really great. Not much mass there. I could put that little tiny point in a lot of places. I can't put one of these rectangular skews. One other thing, if you buy one, whatever brand you buy, the manufacturers tend to these days have this edge flat, which we want. We can do that. They also have this edge flat because it's easier and cheaper to manufacture it that way. But if this edge is flat, it prevents me from doing any kind of rolling cut here. I'm going from the flat up onto a corner, back down onto another flat again, and I find that it's fighting me a little bit. So I would take a tool on the sharp point and I'd radius that. Just go to your belt sander and knock those corners off, radius that. It makes it so that you can do rolls. On the long point edge, excuse me, I always want to keep it square so I can stand it up on the wood like that for V-cuts. What we teach in class is V-cuts are made with the tool standing vertically. We never twist it because the moment I twist it, I get a wonderful spiral pattern. Very decorative, but not reproducible. So when you cock it like this over to do a cut, recognize that it's going to have a tendency to want to move and it's going to want to escape. And so if you're going to do that, that you have to manage that and control it and prevent it. So if I was going to do a deeper V cut here, I start. Is my tool straight up and down? If you're looking really close, the answer is probably no. Because I am cocking it over just a little bit, but I'm hanging on and I'm being really certain that I don't let that edge hit the surface. When you do these deep V's, you can't see it, but on this tip of this tool, there's a lot of sawdust and there's a spot. Yeah, it's so small that you can't see it. I would say it's about 1 millimeter long where there's no sawdust. That's the part of the bevel that's rubbing against the wood to make the cut. If this whole edge touches, you're in trouble. It's going to skate you out again. Joe, comment?
So one other thing that I'm not sure if you find it, but for the radius skew, I can actually make coves in spindles where I can't do that with a straight skew.
If it's a long distance, if it's a long shallow, you can do coves with the radius skews. Now this is half a long. I'll finish it by coming over the other side and probably make one cut. Well, I didn't do a very good one, so I did one cut. So I take all the wood off on one side and go over the other side and just clean it up. The V-cuts are a really practical thing we do a lot of. One of the things I would have put in my book, if I had thought about it at the time, remember beads? when we do the advanced 150 class, which is an advanced beginners class, I ask everybody, what are the things that you need to work on? What do you have the most troubles with as you start? And there's almost two things that always come up: using my skew chisel and doing beads and coves. And so, doing beads, seems easy enough when you see somebody do it. But the point of it is, there are three motions going on. I am raising the tool, I'm rolling the tool, I'm fanning the handle all at the same time, and then I'm going in as the wood gets down. So it's hard because there's a lot of stuff going on. So here's what I've taught, and this is something I want you to take home and try and see if it works for you. I say, go to the lathe, put your piece of wood in place, and stand here with your favorite hand. I'm right-handed, Jim. Put your index finger out and pretend it's a tool. And just do this. Rotate it. 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now I want you to fan it this direction at the same time. Rotate and fan. Rotate and fan. Rotate and fan. Oh yeah, and I'm starting to get my body going with that motion too. Rotate and fan. Rotate and fan. Rotate and fan. Just slip the tool in there, and there's your bead cutting motion. Now, see what happens to the tip? It's all over the place. So I've got to bring this hand in here, and I've got to stop that. I've got to steady it. That's the motion. That's all there is to it. But it's like riding a bicycle. There's so many things to go when you get your bicycle first time. You got to pedal, you got to steer, you got to listen to Dad, you got to do all these different things at the same time. And after you get the motions together, it doesn't seem complicated at all. This is the same thing. Once you get all these things connected together, it's not complicated at all. I have two different spindle gouges, which I want to show you. Well, one's bigger than the other. That's one point. That's not the point I want to make. The narrow one is kind of pointy. And the bigger one is kind of rounded on the tip. If you go to our sharpening fixtures, the ones from One Way or the Sarbies with the belt sander, whatever brand you tend to use, after a while, your tool begins to get just a bit pointy. There you go. See, how can I do that? You stay still, I'll go find you. I'm working the wrong tool. There. See how pointy? It tends to take more mass off the side of the tool and not as much off the center. So as a result, every now and then, you've got to go back here and grind the center a little bit because it gets pointy. Once it gets pointy, it gets harder to use. What we like for beads, there's something that looks more like this. Rounded on the tip, much easier to use. Will the pointy one do it? Of course it will. But it's just tougher to work with. Still works. But I have more control because I have more flatness on the tip here. So it's more fun. Like I'm going to make a bead here. I would start off by just taking the corner of this piece of wood off. And each cut gets a little deeper. And I come around a little farther. And I'm using my left thumb to move along the tool rest. The right hand is doing this stuff.
Jim, have you done, ever discovered that you, partway through your bead, you got a Christmas tree shape?
Oh, yeah, that's exactly what that is. Let me make one of those things, and you tell me what you don't see, or what you do see that I shouldn't do. Okay. I'm going to make a bead that looks like a mountain. Two different kind of mountains. Actually, it's a decorative thing, but it's not a bead. So, what's missing? Turning the tool. It's not rotating. If you just slide it straight down, you'll get this nice pyramid shape. But to get the bulbousness of it, the tool has to.
How do you correct it? What do you do after you realize it's gone wrong?
Get a new piece of wood and start over.
Make it smaller.
Or if you got a lot of CA glue, put it back on again and start over again. But really, it's a matter, when I see that in class, it's because the tool isn't being rotated enough. And one of the things our intervention with the students almost always is make your motions bigger. Tend to do this little thing. But what we really need is this. You've got to turn a lot and a far. So that's where I say this figure exercise is kind of an interesting one to try. I would have put that in the book. I just didn't think of it until, what, 6 months ago? Something like that, not very long ago.
New and improved version.
Yeah, we got to rewrite another third edition. Third edition. Okay, so spindle gouge works is stuff we really need to learn. How else can I make a bead? I have a tool here that is referred to as a spindle, what do we call it? Beading and parting tool. And it's just like my regular parting tools, except it's wider. They're nice tools. Beading and parting tool. This is a bevel rubbing tool. Find my bevel. Boy, does that work nice. Get them better. It's another tool for cutting beads. If you've never tried using your parting tool to roll a bead, and it's narrower than this, try it. This is wider, makes it easier. Let's find a narrow one. Oh, here's a classic diamond-shaped parting tool. We have them in every one of the lathe stands. Will this make a bead? Well, because it's thick, I'm going to drop the tool rest just a bit. Yeah, that's pretty good. I need a little cleanup here. So all these tools do more than one thing. I mean, that's just as good as anything else for making a bead, except because I have to raise or drop the tool rest because of this thickness, I'm going to have to make some minor adjustments. How else can I do a bead? I was going to bring and show you my custom-made beading tool, and I forgot it this morning. So while a couple of you are watching, I made one. It took me probably a total of 2-3 minutes to do that. This used to be, it says Benjamin's Best, I thought it was a 1/4-inch bowl gouge. It is now a 1/4-inch beading tool. What did I do? I took and ground the whole bevel off of it. And on your left side monitor, you can see what it ends up looking like now. So I went to the grinder, and I brought it up like this, and I just waited. I took that whole radius bevel off, and now it is a flat surface, and it is used upside down. So let's make a bead with this. Now, this was a bowl gouge, and so it has a fairly deep set to it. If you did that with a spindle gouge, you would, I'm sorry, a shallow.
Deep fluted gouge?
This is a deep fluted gouge. That's what thank you. Helping me to stay on purpose here. I'll get different depths. If I want a shallow, flat bead, I would use a shallow fluted gouge and grind this way. So let's do it. Loops down, both wings are resting on the tool rest. Now I'm just going to simply roll it back and forth. Haven't reached the bottom of it yet. With that tool, there's a perfect bead, narrow and deep. If I wanted a shallower one and a wider one, I would use a different shaped gouge. A shallow fluted gouge would give a much more gentle bead. And that took me just a couple minutes to make. So if you have an old shallow fluted gouge or an old bowl gouge that's gotten so short that you can't get it in your sharpening picture anymore, consider converting it into another tool. When they're this long, I find them less suitable than when they get shorter. The shorter they get, the stiffer they get, and then they make a nice tool. But there we go. There it is. It's mahogany, so it's fairly soft, and I don't see any tear out on the top of that surface. But you do it by wiggling back and forth. By the way, you want a bunch of lines that are equally spaced. I do a lot of lines on that way by using this tool as a line device, so they're equally spaced. Raises the surface, you get a sandbag, and it feels proud. Another way to do beads. Here is a commercial one. Oh no, this is mine. This isn't D-Ways. I'll be done. This is one I made.
Soon to be commercial.
Maybe a little. This is 1/4 inch. It's going to create a groove that's 1/4 inch deep and 4 inch wide. Maybe for Bob to try for basket loop. And Bob thought that he would like it to be a little narrower. He likes it deep like that because it's part of what he tries to do. So I made a 1/4 inch one. And I made another smaller version of it. And one of the things we do not teach in 101, but we will show it to anybody in 150 here? Ooh, I'm going to give away a secret. Because in the last week of 150, we show you another way to make beads that's almost foolproof. And that's using a diamond point tool, or a pyramid tool, whatever you want to call that. I do not have a handle on mine, I never did. I just find it's easier to manipulate. This is the tool. I had one once, and I tried to cut with it, and it didn't work worth squat. And I finally had somebody tell me how to use it, and it started working really well. This is a scraper. This is not a bevel rubbing cutting tool. This is a scraping tool. So I'm going to go into the wood, and I'm going to make a V cut. By the way, these are nice decorative marks. I'm going to come over to the other side of where my bead's going to be and make another V cut. Flat is up. That's that's part one. Okay, so that's going to be my bead. Now, here's the trick. You go back into this first one, and you roll the tool over and bring the handle around and come out of the bottom towards the top. Don't go down, bring it out. So it's scraping, but it's scraping on the out pull instead of on the push in. Does that make sense? Pulling it out instead of pushing it. So, start here. Other side, oops. And if that edge gets dull, oh gosh, I wasn't watching. Change to another face. Nice thing is also I can make really tiny ones. I was going to tell you, you do not get catches with this. But I'm going to avoid saying that. But in general, it doesn't catch near as much as doing it many of the other ways. So, straight in, drop the handle, rotate the tool. Other side, straight in, drop the handle, rotate the tool. And it's probably the easiest way to make these. Now, one nice thing about this, I'm doing it on spindles. What if you're on a platter? You try to use a shallow fluted gouge, pointy one best, on a platter where the surface is vertical, maybe not very well supported from the back, and you'll find it very difficult to do. Try using the diamond point tool, you'll find it so much easier. I always make sure the back of that platter is sanded so I can put my hand back there and support it from the back side while I'm doing it. So this is my preferred way for small beads. Another technique. Drill rod. just ground to 3 faces 120 degrees apart. And you can do it by hand, manually. The easiest way to do this is get a nut, hex nut of any kind. If you drill a hole through it, put a little set screw on the side of it, you know a hex nut has 6 faces, right? Every other face represents 120 degrees. So I go this face, click, click, I'm at this face. So you can make yourself a device for sharpening these things or making them by any hex nut. Set screw in it is the hard part. If you get a hard nut and try to put a little set screw in it, that's a difficulty. What I do is I actually have a piece of plastic that's made into an isosceles, no, it's an equilateral right triangle. Equilateral triangle. Can be equilateral and right at the same time. It's an equilateral triangle. And I put a hole right in the center and a little set screw, and all my tools go in there. And when I make these things, it takes me minutes. I go from face to face to face and keep going around. So this is a really good tool to have, one of these. You buy them commercially, and you can make your own. Everybody have one now? Good, I have one.
Do you have any for sale in the back yet?
I don't know, there might be a couple back there. Yeah. Okay, so spindles. Decorative work. One of the things we may want to do is take these little lines here and burn them in on a spindle project. First thing I do is move the tool rest out of the way. Second thing I do is find myself a burning wire. Now, burning wires have several characteristics. First of all, they're made out of really rough, cheap wire. And Karen, are you still here? Karen Rice gave us a whole bunch of really beautiful stainless steel wire of all different gauges that comes out of surgery, which they could not recycle through MedShare. Didn't make good burning wires. It was too shiny, too polished. It didn't develop enough friction. So what you want is a really cheap wire. Some of these coated wires are, if you have violin strings, guitar strings. The nice thing about a set of guitar strings is the fact that you have 3 or 4 different gauges. You can make 3 or 4 different widths of them by having all set of strings. Sturgeon leader, if you're a fisherman, because they're wrapped wire, they do really nice. The second thing they all have is handles. You know why?
Yeah.
Okay.
Cut your finger off.
So one way to do it on flat surfaces with a burning wire, of course. I got mahogany, so it burns really nice. Just that fast. Nice decorative marks. It does raise the grain, and this would, if you had sanded this and then put your burning marks in it, then you'd have to go back and with one of your final grits take some of the burrs off. This raises a little bit of a burr. Bob Nolan puts a lot of burned lines on his decorative pieces. And many of those things are on the inside of a curved surface, like the inside of a bowl. How do you use a wire in those circumstances? The answer is you don't. You got to find another way. You go to Home Depot and buy, or go into the home department where they're selling countertops and cabinets and stuff. They have racks of samples of countertop materials, sort of like Bakelite. Grab 2 or 3 of those. The edge of that burns very nicely. So I use them and then they get consumed. This is Bob's burning tool for small projects. I have it in an oversized handle. It's a dental tool. Do not use it with a hookup, please. More than once. Or you have to go back to see your dentist again to rip off some more tools. Oh, you come over here.
I never developed enough friction.
It's stainless and it's polished, and you think it doesn't have enough friction, and you have this weight. If you're on the inside of a curved surface and you need a bead, something like this or the Bakelite is probably the only way you're ever going to make it happen, because you certainly can't use a wire. It doesn't work. Or you can always use a burning tool of some sort. But this works out really nice. The reason I have it in this handle, there's another hook like this on the other end. And I'll make sure it stays in the handle and not in me. So Bob uses a gizmo to prevent himself from getting punctured. Another way to do beads. My wires are, I think it was a set of violin strings. Maybe they're guitar strings. I don't even know where they came from, but there's four of them came, and I have them in handles, and each handle is color coded. So where they hang, I can tell which one's the small one, the medium, and the larger one, and put the right one in the right place. You can also use your skew chisel by misusing it. By not moving it. I didn't make as good a line, but it did burn. It's great for keeping the tool dull, too. Okay.
You want to take a break, Jim, or
Yeah.
do time, or no? Let us know.
You want a break?
Let us know when is a good time.
Want a break? No, nobody wants a break.
All right. Don't let us know.
Enough of that. Let's look at bowls. Bang for the bowls. So, first thing we do in most of our bowl training, we use a chuck. And I think this is probably going to drive a lot of you nuts. But how do I rough out and get the tenon on my blank? Like that. Here's a blank. I got to get a tenon on this side so I can make a bowl out of it. Anybody do this?
No. No. Works great.
I do this a lot.
How do you
Now, I
center it?
suspect you'd probably like me to put a face shield on.
Is the glass okay?
The audience has a question.
Push it up or just?
The question is, how do you center it on your chuck?
I put it in the little hole that I pre-marked.
Okay.
What I did, yesterday when I came in here and set up to do this thing, I put this thing on here, centered it by eye, so it was relatively centered. Turned a little bit, and I found I was taking more off of one side than the other, so I moved it over a little bit. And made a couple more cuts, and it looks like it's pretty centered, so I just drew a circle around that spot. So it's all by eye and by guess. It really is by guess, yeah.
How good is a plastic shield?
It's like sand, it's almost bulletproof.
Almost.
Now it's,
Okay, so
you have
bowl gouge.
I like our safety.
Deep fluted
gouge, deep fluted.
Works really well.
Deep fluted gouge. Where's my deep fluted?
So this doesn't
up.
record, right?
I see theirs, but oh, here's mine. Again, a little different. I don't like long handles. I also, my handle, if you can see it, is not round. It's triangular. Also has a little dip right here. So when I pick this tool up, without even looking at it, I know exactly where the flute of this tool is. Because I've held it, my fingers wrap around this thing. I know exactly where that flute is without even looking. So I find I get by with most of my gouges have extremely sharp flutes, sharp handles, and I find that convenient.
How'd you get your handle that way?
I'm sorry?
Did you plane your handle?
Oh, no, you have to make these things. So what you do is you have 3 axes, 1 4 axis, so center to get it round, and then 3 axis, 1 over here, which causes it to go this way, creates a flat here. Okay. 120 degrees around creates a second flat, 120 degrees creates a third flat. And on one side, I just didn't go all the way. I left just enough for my thumb to rest against this spot right here. So this is just where my hand fits. To me, this is very comfortable. Other people like the really long handled bowl gouge. It's just, I'm okay with this. Not okay with being able to see. So, when I turned this on, this is a piece of oak and it's somewhat green, and it's a little out of balance. It was better in balance yesterday, but it's done some things to itself as the time has passed. So I turned up this, I always start with the speed really low. And now I'm going to bring the speed up. And I found the spot where things started to vibrate. No. And actually see the monitors bouncing. Now watch what I do now as I keep going. I went past the vibration spot. So you'll see professionals many times do that. They will turn the speed, you'll see it vibrate, and they'll continue to increase the speed. I went past the point where there was a resonance spot. So sometimes you can get away with that, other times it's not safe or appropriate to go too fast. I could pretty well shape the whole outside of the bowl this way if I wanted to. And I'm still bringing it into my body like you would with the longer handled tools. I had to move my feet. I was out of balance. I had to move my feet. So let's go in here and get a 10. Let's go in here and get a 10 of them. Actually. Okay, so I have a place where the tendon's going to go. Now there's a lot of ways to do it, and for me, one way is to use your gouge. I can come in here straight. I can come in here straight. The problem is the corner at the bottom. If that corner is rounded, your chuck isn't going to hold well. I have to get rid of that. So what else can I use? I could use a shallow fluted gouge, thus not calling it a spindle gouge anymore. Dovetail if I need it to be. And I've got a nice clean corner. I could come in with my skew chisel, square it off this plane. I'm leading with the long point. The tool is absolutely flat. And I've created something that's almost flat. Now I'm going to come in from this plane and take off any problem and take the point down in there, and I've got another 10. Another way to do it. Dovetail, really easy. You just push in further with your skew chisel and you've created your dovetail. What else could we do with it? A lot of times we use the parting tool. And to me, this is my least favorite way. because the quality of the cut I get is worse. You still hear me okay?
No, no.
Gotta be up here, doesn't it?
Yes,
I don't like the popping sound, but I'm sorry about that.
no problem.
So my idea with the parting tool is I'm coming in like this. I'm tearing right into the end of those fibers. I'm not getting as clean a cut. And if I go straight in, I'm not cutting, I'm scraping. So I'm not taking advantage of this tool's best characteristics, which is to rub this bevel and bring it in. So I'm coming in a way that I'm not maximizing the best use of this tool. The spindle gouge is easier. Skew chisel or spindle gouge comes out to be better ways of doing it than with the parting tool. By the way, this is an Ashley Isles parting tool. I don't think you can find it in the United States. I picked it up at a garage sale. Look at that. Wow. Round stock, bevel down here. It's so stiff. It's a great tool. Then it was just a blade I had to make the handle for it. But that was just, for a parting tool, this is just great. Happy with it. So we can shape this thing down and make it into a bowl, right? Any questions about tendons? Okay. Bowl. Tenon. Foot. Outside, roughly shaped. So we're going to put it in the chuck. There we go. To get the key to set out. I tighten one. I tighten the other. And as long as I can move the key, I keep going.
They do different things? They do different things? Each spot tightens differently?
No, they're two, in this case, two opposing gear wheels against that spiral internal gear. They're exactly the same.
So why move it?
Because I want to keep tightening, and I could unevenly apply pressure on one side and it might bind a little bit, so I'll kind of loosen it up and tighten it on the other one. On your Jacobs chuck, when you put a drill bit in, you tighten all three holes.
Yep.
Same idea. So, a couple of things I want to show you here. Outside probably looks okay. Yeah, it's still not pretty true. It's amazing. So, one cut I see a lot, and I'll do it here on the inside. Should have done on the other one, but first thing I'm going to do is remove this thing that will impale me. If I don't, I have a shark bed lathe at home, so impaling myself is easier. I used to have a long bed lathe and I needed more space. Need more reach. One of the cuts that we would teach is to start with the tool vertical. Get that bevel cutting here. Create a small shoulder for the tool to rub against and then open it up and come around. Sometimes we teach in the center, kind of a rolling a boat kind of motion. In this case, I want to face the tool in the opposite direction. I want to hold it backwards. I don't want the fluid towards me. I want the fluid away from me. My thumb's on the straight portion. Now, all I've done is go straight down and create a little bit of a groove. And I've seen a lot of people, the tool bounces off. Create a straight spot. Now, I can open it up as I come around. How's my thickness? Pretty good. Never go backwards like this. You're not supposed to shear scrape inside like that, right? I just did it, so it works fine. Yes?
We can't see the tool.
Huh?
We can't see the tool, we don't know what to do.
Well, that's the point of it, right? So I'm going to start off with the tool totally vertical, like this. And with this bevel, absolutely lined up with the outside of the bowl. They are parallel. And I go in here and go straight in. And what that does is keep this thing from skating off one direction or the other. Open it a little bit this way, I want to skate that way. Open it this way, I want to skate that direction. So what I want to do is go, ooh, I'm going to go straight in. And I'm going to go down enough that I have a little shoulder. The edge of the tool, the cutting edge, is resting on the shoulder. And now, as I go down, as far as I can. This is the trick to getting this cut started, is getting that tool vertical and getting this edge, this bevel, lined up with the outside. Straight down, create a small shoulder. The tool now has support at the tip. I can now follow the shape of my curve down. Does that help? Yes. Can you shear scrape inside a bowl? I just did. If I find my tool, I'll do it again.
You did, you said never. You said never.
What?
You said never.
Oh, never do this. Let me show you what not to do. You get these ridges in here, how you gotta clean them up? Well, what's wrong with I'm doing a shear scrape just like you do on the outside of a bowl. I'm not seeing many people do that, but I don't see any reason why you can't do that. It's perfect. I get a nice surface. It's a little thin in there right now, but I know how to fix that. But now I got to pick it up down here at the bottom of this and continue on. Now I'm going to reach a spot about there where I can no longer rub the bevel of the tool against the bottom of the bowl, and I am now doing what I call an unsupported cut. I am cutting with the edge without the bevel on the wood. There's a point at which I'm either going to run into the rim or something else, and I'm not supporting this. Do you do this cut? Only if you can hang on real good. Do you get a quality cut? Not as good. Do I do it? Yep, because I can hang on. So I would not suggest if you're a beginning bolt turner to try that. To find an alternate method. Sorry about that. I reach that spot where I can't keep the support back here anymore. My solution has always been to go to a nice big fat round nose scraper. The bigger tool that'll fit is the best tool. So the bigger it is, the more mass it has, the less it's going to vibrate as it hangs over. The problem with scrapers that are too thin, they're going to vibrate like a banjo string. Yeah.
Jim, it sounded like when you were making the initial cut in that bowl, that the tool was vibrating. It sounded like it was vibrating.
It's this. The bowl is thin enough that it's beginning to vibrate.
Did that leave an uneven surface?
Not that I'm aware of.
600?
You could have. When you start hearing vibrations, it's either a pitch. If it's a low pitch, it's normally the wood. If it's a higher pitch, it's normally the tool. And so if you have a tool hanging over the tool rest and you hear kind of a high-pitched vibration, that means your tool, this whole heavy thing here, is actually flexing. If it's a lower pitch, it's normally the wood that's flexing. So if the wood is flexing, my hand goes on the outside, because I've sanded the outside to 180 ahead of time. If the tool is flexing, I'm either going to get a bigger tool or get the tool rest moved. Trick on scrapers. If that blade isn't going downhill, you're at risk. If it's level, or the handle is lower than the blade, there's a catch waiting to happen. So I find the center, I set my tool rest so that to reach the center, the handle has to be higher. And my solution for making sure that always happens is to rest it on top of my arm. If I do this, when I go in here, this handle will always be higher than the blade. And my index finger is always along the side. It, for me, is a help of knowing where the tip is going. Now I'm going to work from the center out. Rather than from the edge in, because it's less aggressive. Can I cut both ways? Absolutely. If I go this way, the cut is more aggressive. If I go this way, it's less aggressive. There's that sound. That's the wood. And this is not a lot of hard work. I'm just holding the tool in place and I'm using my left hand to slide it along the hole until we reach the center. And the center I better stop. Because if I go past the center and keep cutting, it's going to pick it up, bring it around, and slam it back down the tool rest. And if my hand's underneath, it's going to hurt my hand. So,
Jim, did that tend to tear out?
Say again.
Did that create tear out?
If it's not sharp, yes. If it's sharp, not too bad. Not too bad. I finish off a lot of pieces with a scraper. We call that the end of the process. Got a little bump right in here. Let me just get it out real quick. I can't see it, but I can feel it. Ooh. Better to pull than push. There. See that? That's the wood vibrating. I'm out here where the wall is fairly thin, and I'm a long way from the chuck, so to stop that, when you get vibration, you've got to eliminate it, because it'll put marks on your piece otherwise. How do you eliminate vibration? What's one way?
Slow down. Put your hand up.
Back it up.
Okay, like I was doing, get something here to dampen the vibration. My fingers in this case was helping. What else?
Steady rest.
Closer to the.
A steady rest, if I could get something closer in here. Get my tool rest in closer to the surface. Shorten the length of this tool. Good. What else?
Change the speed.
Change the speed, because we're at a resonance point. Either up or down. Doesn't matter. But out of that resonance point. What else?
External is steady rest, I think.
Oh, steady rest. Okay, what else?
Sharpen your...
Change the pressure you're applying against the tool. And the most important one of all is
Sharpen it.
go sharpen it. Change the amount of cutting force that you have. So, you've got to change something. Yeah?
Say something about when you sharpen that, to the extent to which you are using a little bit of a burr to make that cut.
So, if you have a burr pushed up on one of these tools, on softwoods, the burr is the cutting surface. On the hardwoods, like this piece of, I think it's oak, by the time the second cut happens, the burr is gone. So how am I going to sharpen this thing? Well, you can always go to the grinder. Because I've written on here what the angle is. This is 11 degrees on my tools, 15 on all the ones here in the classroom. So I'd rather not go to the grinder and sharpen it. So I'm going to sharpen it another way. Can we see down here? We can't see down here. Can we? Oh shoot, that's too bad.
We can get. You want to try?
At home, this is bolted to the counter. And I'm looking for my C-clamp, which is right underneath my right up here. This is probably not going to work, but we're going to do it anyway. We're going to try it. Okay, what I have here is a scraper burnisher, and you can see it on that camera over there. It's a pin, which is fixed, And there is a pin that is carbide that can be removed and put in one of two different spots. This is the one from school. Mine is bolted down. So you take this tool, and your very first step is to be sure that this surface here is flat. So I'm going to just do this. Actually, a belt sander works fine. I have a disc sander at home. I just go up and rub it against the disc sander. I don't turn it on, but I just rub it against the disc sander. I want to make sure this is flat. No burr, flat surface. That's what I'm going to do now. We'll put it between here and roll it around against that carbide pin. And that's it. I didn't push real hard. There's a burr. Okay, so no.
Jim, what about a negative rake?
Oh, okay, good. That's enough. John Louis checks it now. Now I gotta have it back. Is there a burr on that? Yes. Okay, that's good. There is a burr. Okay. You can also take the handle of a screwdriver, hardened blade screwdriver, and do it like this. This is high-speed steel. I can push a burr up on it that easy. Now, make a couple cuts. Guess what happened to the burr? It's gone. So I'm right back here to my burnish again. Can I grind it? Absolutely, I can grind it. But I don't need to put all that energy into it, wasting that much metal. I'll just raise my burr back up. Now, you asked about negative rake. Good question, because guess what I was doing when I was presenting that tool in there? What angle was it? Negative. It was a negative. It was a negative angle already. The big thing about these negative rake scrapers that have come out is I can go in here with it flat like this. Since the edge is down at 5 degrees or so, it's the same as my tool going in like this. All the same. So if I hold this tool properly, I've had my tool going in at a negative rate.
So that's all a negative
rate. That's all it is. Now, you want to put one in there because I'm going into this box. I can't get the handle high enough because it's a small thing. I don't have room. Then I might go and actually take this to my grinder and put about a 5-degree backing. I don't care what angle. Just go to the grinder and whiz it once, and you've got a negative rake on it. Then you can go into a small opening horizontally and know that the tool is not in a catch angle. Ed?
Card scraper would also eliminate vibration.
Well, Ed brought up card scrapers. You ever clean the inside with a card scraper? I think when Brad Evans did his presentation a number of months ago, he talked about using card scrapers. This is a set of 4 pieces that came from garlic. Most of our cabinet makers know about these things. But in this set is this nice French curve. All these wonderful angles which can fit in here. There's a portion of this that's going to fit that bowl someplace. How do I get this sharp? I could use that same thing, but you know, Veritas actually makes a device for sharpening these. Tool slides into here, into the slot, and I push it around. There is a pin right here, a little carbide pin, goes into the hole, and the angle, 15, 10, 5, 0 degrees. I can actually set the angle on this. And all I have to do is put it into the slot, press it around. I've raised the burr.
Where do you get that?
Malcolm Tibbetts, who does a lot of segmented work, you'll find him on his pieces when he's finishing. He'll put a coat of shellac on the outside. He'll then come along with his card scraper, scrape it down, another coat of shellac, scrape it down 2 or 3 times like that. Not with this thing around here, we don't. Nice way to clean things up. And I don't know if you can see it, but I'm actually getting shavings. Yeah.
Would that get rid of tear out?
Yeah.
Yeah.
Oh, yeah. It's great for tear out. Better than sandpaper. Because the sandpaper is digging us grooves in there, right? We're digging smaller and smaller grooves until we can't see them anymore. This is slicing the fibers. So still, to get rid of tear out, you have to go below where the tear out is. If there's a hole down there where a fiber's been pulled, we have to cut below that, otherwise you'll never make it go away. So what's our time like? It's 11, we want to go to what, 11:20 or so you can get your wood raffle in?
Hey, Jim, what about greenwood? Will it work on greenwood?
Yeah, better, less dust, easier to cut. Greenwood is always, if you're just beginning to do bowls, try to do greenwood bowls almost all the time because it's so forgiving. You get a catch, it lets you go. You don't create the dust. There's all sorts of things about greenwood. Of course, most of it's free because you have a wood raffle or you have a neighbor who has the trees coming down or did come down and you got the source. So work with a lot of green wood. It's just much more forgiving. The dry wood is...
Jim, where do you get that device that you sharpen it with?
You can buy these at any woodworking dealers,
No, I mean-
Island Hardware, Rockler,
Veritas.
oh, the Veritas,
Lee Valley.
Lee Valley is the one who sells the Veritas line. You gotta look at Lee Valley's catalog if you have anything. They get a lot of stuff made out of brass and it's just gorgeous looking tools. I mean, it's just really nice stuff. I just found this in the cabinet. I don't use it, but I found it yesterday and I spent some time digging around trying to find all the pieces for it. The wood piece in one place. This insert was in a different drawer. Why these were in different places, I have no clue. But I want you to see that there is a device for it. How else can I do it? I could do it with that same carbide pin. I could also do it with the shaft of a chisel. 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 Do I have a bench chisel here? You could very easily use a bench chisel because it's a hardened steel. Yeah.
I've heard several people say that you can go down to the junkyard or whatever and get an extra valve that came out of an old car, and the steel on that is so hard, it's just perfect for that sort of thing, and they probably give you one free.
Yeah, it's a tool steel that's been hardened, and yeah, shaping it and grinding it, you'll have to go to your grinder to do that. You can't cut it, but you can grind it. Get a peanut grinder from Harbor Freight and put one of those carbide or one of those abrasive wheels on it. You can cut and shape it really easy. You can use your aluminum oxide wheels here to grind and shape it. You do not use your CBN wheels because it will load them. And so it's not good. So if you load them, then you're going to have to clean them. So the CBN wheel should be held for high-speed steels and for carbide tools. Yeah.
On the larger scraper that you had that was a left-hand edge on it.
This is the right-handed one. There's the left-handed one.
No, the longer one that you had that was massive. You said the ones in the shop are at 15-degree angle, and as a beginner, should I have a 15-degree angle as opposed to 11 on that one?
It doesn't matter too much. All of ours here are 15 because I have the platform locked in at that. Mine's 11 and it's insignificant difference.
And on your grinder, for grinding that scraping tool, what size grit should I have on there?
80.
Thank you.
Don't use anything finer than that. Because you're dealing with a piece of metal that's really, really thick, and you got a lot of metal to take away, so you're going to use your coarser wheel. Otherwise, you'll be grinding forever. If you're looking at your standard aluminum oxide wheels that come with your grinder, you typically get an 80 and a 120 wheel. I reserve the 120 for my gouges and my skews, and I reserve the 80 for all my thicker tools, which is almost always roughing gouges and scrapers. By the way, if this size and this shape doesn't suit you for your project, ooh, this camera may work out really well here. If that doesn't work for you, that curve is wrong, I can't do it. Just rotate it up on the edge. This will work. Okay, so I have a small curve in here, and I have one scraper, and it doesn't fit. In other words, it doesn't set there. What if I turn the tool up on its edge? I've changed its projected profile to a different curve. So with the big scraper, in a proper distance and so on, I said, that doesn't work. But I could turn this up on edge and create a different profile with two. Now, is there danger in this thing?
Yeah.
What's the danger? Yeah, first of all, don't put your finger behind it here. Second thing is, if you do get a catch, it's going to slam it down on the tool rest with a vengeance. The other thing is this edge, which is square, does not allow you to roll it very easily. So what I did on mine is I ground this into a radius, thus allowing me to be able to lay this tool and rotate it with good support at different angles. So you're going to find a bowl, a box, or something that has a curve in it that your scraper doesn't fit. And so all you've got to do is take the scraper you do have and find at what angle does the profile match. And then carefully, still driving it the same way. Remember that you're pulling and not pushing. You'll find it'll fit. So I can generally get by with 1 or 2 scrapers. When I'm doing boxes where you're limited access, then I have other scrapers because they have to fit. I don't have the opportunity to sometimes play with weird angles.
Do you like the longer handle for the scraper, even though you're using the shorter handle for a lot of other things?
Yeah, it's always longer because I want to support it on my arm. I want to be sure that my presentation is like this. I have some scrapers that are smaller, which are shorter, so they're not all the way up to the elbow, so they're supported more on the forearm, but they're always on top of my arm. Just a habit I've developed. Habit that always allows me to be sure this is lower. Yes, first.
Jim, when you're doing that though, you get some catch. Don't you risk the handle from flying up at you?
I've never had that happen, but I understand that that's a possibility. But remember, it's on the tool rest, and I'm hanging on to it here. That'd be a pretty huge catch. But what'll happen when this handle is higher, you won't get a catch. You'll get this tool come like this and release. Instead of grabbing it on the wood and pulling it up, it actually pushes it down and releases, so it goes away from the wood surface, and you just basically stop cutting all of a sudden. The handle will come up a little bit, but it basically just releases. That's a good question. Yeah, behind you.
Yeah, how often do you raise the edge of it with the burnishing tool relative to grinding? I mean, do you grind it every second time, every fifth time?
I try not to grind it at all.
Really, just get the profile set and then just use the burnishing tool.
But always remember that you have to have some way to flatten that to get that burr off. I've got to get that edge nice and crisp and sharp because the amount of metal I'm pushing up is very small. But if this is kind of rounded over this way, then trying to push up a burr isn't going to happen. So belt sanders, disc sanders, cards. I carry a card in my pocket, as most of you already know. I just figure out which pocket it is. It's the size of a business card, which is great because it fits in here with my business cards. And you can pick these up at every woodworking dealer.
It just doesn't work in an ATM.
It's the size of a credit card. And they come in several grits, from coarse, very coarse, medium, fine, and very fine. This is the red coated, which is a 600 mesh, which says fine. So it's not the finest, but it's not the coarsest. My sense is the coarse one doesn't do the surface I want, and the very fine takes too long. So if I was going to use this, I get a flat surface against a flat surface. It works out. Works out. Nice. Everything's backwards, isn't it? I go over here where I just stick with my tool there. You can actually see a little burnish mark right on the edge from me having cleaned that up. By the way, anybody have carbide tools? The C word? Do you sharpen them?
No.
Yes.
Why not?
Because they say you're not supposed to.
Because the manufacturer says buy more tips.
Damn things are expensive too.
I have a couple carbide tools. This is not mine. Thank Vern for bringing these things. I've got to ask him to bring them in. Here's a carbide tip. Standard carbide tip. It's flat. The screw is recessed. If this is carbide, what am I going to cut it with?
Diamond.
Diamond? What's on these sticks here? Diamond. I can sharpen this thing. I'm going to take, I happen to have a medium right here. I'm going to lay it here. And I can literally sharpen it by working on the flat. I don't raise the edge, I just work on the flat. By the way, no fee. It's no problem. That's the flat one. How do you do a round one?
Take it out.
Exactly the same way, because the screw is lower than the round piece. I can do that, I can unscrew it, take it out and lay it on this thing and rub it back and forth, or on my diamond card, that works fine. So there's no reason you can't sharpen these things. Now, replacing them is fairly inexpensive, so it doesn't matter, you can buy a new one and rotate it every couple degrees, yeah.
What grit are you using to sharpen?
This one I just grabbed at the mid, it's called medium, it's undefined, so my sense is that's probably around 400, because I know the fine is 600 mesh. So you can sharpen these things. Don't on the round ones come up here and try to dress the edge, because you'll mess it up. It will no longer be round. Router bit's the same thing. You don't sharpen the profile, you sharpen the flat of the router bit, because anytime you go into the curvature of a profile, you'll mess it up. So these work great. Was another question back there? Yeah.
So the one thing to be careful with the rounds is hunter carbide heads actually have a raised top surface, so it's not a flat top surface. So I don't know if you've got a jig doing.
Now these carbides, now this screws lower surface too. You know, they're only not that much you could easily. This one has a cup shape to it, which has what in metal terming we would call this a chip breaker. But it's the same way. I could still do this here.
But are you?
What I do like about this tool, Joe told me they're discontinued now, which is disappointing.
Eliminator.
The Eliminator is called. There are two versions of it. What's nice about this is when I lay it on the tool rest, look what it does. It puts it at a 45-degree angle because the back is V-shaped. So instead of going in like a scraper and digging out wood, this brings it over at a 45-degree and allows it to literally shear the wood fiber, which is really nice. So this actually cuts wood in the way I would like to cut wood, shearing the fibers. Mike Jankowski came here and did one of our summer master classes a few years ago, and he has what he calls his pocket rockets or something like that. Same thing. You present that inside your hollow vessel at a slight angle, it makes a nice clean cut. Very small tip. And yet you can rotate these things. They're so cheap and just throw them away, and you know, it's really not necessary on the smaller ones to sharpen, but you can. Yeah, Ed.
Demonstrate how you use that concave, the other one, the one before this one.
Eliminator.
Eliminator.
This guy?
Yeah, the Terminator.
I tell you how I'd like to use it.
That's the cup one.
So I talked to the guy who was demonstrating this at one of the shows. He did not work for the company. He was a paid demonstrator, so he and I talked. I said, now they want you to go in here, lay this flat on the material, and go straight in. You know what that's going to do? That's just tearing fibers out. What I'd like to do is to go in at a sheared angle. I'd like to rotate that a little bit. Why don't they make the back of this thing round? You didn't have the answer either. But I'm going to do the same thing here that I would do. I would put it on this corner. I've not tried it before, I don't like it yet. Now, I've cocked it over because I want to share with the thing. I don't want to scrape. Let's see what it did. There is a knot right on the rim of this bowl, which makes this carbide tool a nice tool to cut through that knot. Now I'm feeling the surface I just cut, it's pretty smooth compared to the area below, which is feels a little rougher to my thumb, which is what I did with the scraper. So in essence, with this thing at a sheared angle, rotated, and reasonably sharp, it did a reasonably good surface. But I did not want to present it flat.
If you take it straight in, it has a tendency to catch, right?
Yeah. There's your scraper again, and that's that catch that will happen. I've seen a lot of people use it that way, and I understand it takes away wood, but that's not, it creates a lot of work for you. You gotta love sandpaper. But I can tell in the area where I cut, it was pretty good. Joel, you have a comment?
I guess if you're doing acrylic work, there's some more advantages of the carbide tip.
Okay, so Joe's saying that if when he cuts acrylic, he finds the carbide tools to be much more useful. Do you present them straight or do you shear?
I'm using the really small ones, so it's probably, I'm probably more straight, but it's a much smaller tip.
So Joe's using a very small tip to do that on his carbides, on his acrylics. I would, if this was my tool, I would take and knock these two corners on the back off and radius this so that it was a U-shaped thing. And now I can lay it on the wood at any angle that seems to work for me, and I would feel much more happy with having one. But I don't need to do that because I can manage.
Not as idiot-proof.
Better. But these guys designed it right. I can only go those two positions, 45 degrees one way or the other, because they shaped the back to allow this to work in a shearing presentation. It's a good design. Stiff shaft all the way down, small cut. And there's always your 80 grit gouge. Okay, it's up to you now. The only thing else I want to talk about is a little bit about sanding. But before I get to that, let's see if there's any other questions. Yes?
One way to get the bottom of the bowl would be to flatten the angle on a gouge.
What we call a bottom feeder gouge, right. I didn't bring one up here, but the reason we can't get to the bottom on many bowl gouges is that this angle prevents us from being able to stay on the bevel without the handle running into the rim. The way you solve that is to blunt this angle up so that the angle is someplace maybe 5 to 15 degrees. Now I can ride the bevel with the handle almost sticking vertically here and come all the way across. There is a learning curve associated with those. It's not like the regular one, but once you figure out where the bevel is and how to do it, and Pete's bringing me our, thank you. This is ours, one of ours. Doesn't look very nice, but it works. So the bevel on this one here is very, very short. So I can't, to get here, I'm way over here. Time I get down to the bottom, my handle is not going to run into the rim of this bowl. So you take an old bowl gouge. This is a great one because it's short. There wasn't much left. And then you just simply take this bevel angle and bring it up to about 10 or 15 degrees, whatever works for you. And this is ground straight across. So you don't change your fixtures on your grinding system. You just go up to the platform and just sharpen it like this. And now you can come in here and manipulate all the way across, and you've got stiffness because it's short, which works really, really well for you. Now, you'll have to practice. Because it's not going to cut quite the same. Yeah.
Every time I see Mike Mahoney, he always pulls that out, and I cannot figure out how to get how to get that grind. So the trick is there a trick to it? So you said you keep
Here's what I would do.
Keep your fixtures exactly the same?
Go to the platform.
Okay.
Find what angle you want this to be at, roughly, and just pick an angle. 10 or 15 degrees. Hold this here and just simply rotate the handle like this, like you would do a spindle roughing gouge when you're sharpening it. That's going to create a symmetrical bevel. You haven't got your wings pulled back. If you want these corners pulled back a little bit, then you can wiggle it just a little bit at the very end of your curve. What Mike does a lot is he has a very deep flute. Can't show it to you, but I can do it like this. What he's able to do is take this long wing and go in and shear with it all the way down the side. So he's using it in multiple different directions. So by the way you look at his tools, you'll find the left-hand side and the right-hand side of his tools are ground differently. He uses one on the outside of the bowl and the other side on the inside of the bowl. So he doesn't have to carry as many tools when he travels.
Is there a trick to catching the bevel? Because I once I've got it, I've tried to make these things and I just can't catch the...
It's the old ABC again, angle bevel cut. What you do is you put it on so that the bevel is rubbing and you're not cutting any wood at all. And you keep raising the handle. Here's my sample. Here it is. You start off like this, so it's not catching anything. And I'm going to raise the handle in the direction of the flute. The tool's here, up is here. Tools here, up is this way. And you just keep raising it until you get a little bit of dust coming over the tip, like what I did with the skew chisel. Did Mike just go off? No, it's okay. Now, if I'm coming around the bottom of the bowl, I might have it like this. Remember, up now is more toward you than toward me. So I'm going to rest it, raise it so I see some dust, and then freeze. Raising it farther gets you in trouble. So sometimes we find the cut and then we go beyond it, and that makes it more difficult. Yeah.
I find that a lot of times people use too much pressure when they're trying to find that angle. And when you put too much pressure on your hands, you do not have the dexterity that you have with lighter pressure. And so if you lighten up your touch, when you raise that up, you will feel it when it hits the other edge, and you'll have it nice and flat.
That's a great point.
And the same is true with your diamond home. If you just set it on one, it will just very lightly come up to where you touch it. If you put too much pressure, you won't feel it.
And the same thing applies to skew chisels. What you do is with the lathe off, put your tool in position, and like Carmen's suggesting, raise it until you feel that place touch. Do it 2 or 3 times. Aha, I know where that handle is now when it's getting ready to touch. At that point, turn the lathe on and make your cut. So you kind of know where that position is going to be. You have anticipated. On the skew chisel, I like to lay it there, raise it. You'll feel that flat come up, like Carmen was saying. And I say, okay, now I know roughly where that's going to be when I get ready to make the cut. A couple more quick comments, and then I'm going to close up with sanding. Yes. Joe first.
Yeah, on the bottom feeder, what you hadn't talked about is what angle you're going to present the flute to the bottom. I know you're going to hit the bevel, but typically are you opening it up at 90 degrees, so flat, so the flute is totally open, or you're
I'm coming at it like this.
Yeah.
As I come around towards the bottom, when I hit that dead center, for me, that tool is vertical.
I think that's often one of the problems with bottom feeders is getting that angle right as well as the bevel.
Again, be cautious that you got a cut going and you go past the center. It's easy to go past the center, and once you go past the center, you're at risk because it's not trying to lift your tool down instead of push it. Now, this is what I do. Others may say, I keep it this way. I know Mike Mahoney tends to set it and just come around at the same angle until he hits the bottom. As his technique, mine's just different. I'm used to the way I do it. It works for me. You find one that works for you. So, yeah, another question I saw. Yeah, Jim.
I think my best tool is wood that I don't like, and practice that bottom feeder on a piece of wood that you, when it hits the firewood pile, it's still just firewood.
Yeah, well, firewood with holes in it burns much better too. But yeah, okay. We finish up something, and your outside's pretty close. And you're going to sand. And I have some imperfections in my curve. It's not a bad idea to use some really wide sandpaper. Because I don't want to make a lot of dust, but as I sand around here, what I'm doing is blending the high spots and the low spots out. Narrow strip isn't going to do that. So if I was sanding this piece, I can tell you right now where the high spots are. Here, 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 here. Because I see the spots that I've just touched with the sandpaper. So if I just keep going with this thing with a little dust collection, I can actually perfect this surface. But wide piece of sandpaper. And don't do 220 because why? Start with 80 grit, 120, don't miss any grits. 80, 120, 180, 220. Stop where you want to. The other thing is dust. We always have this problem with dust. And here we have just added a whole bunch of small dust collectors with these big lathes, so each one has its own individual dust collection because the air can get blue in here when we have a class, and I don't like that. But there's other ways to eliminate it. Here is one. Sanding wax. This is a Watco product. It's a wax solvent solution. You put this on and sand. The surface now is wet. It's waxy, so it's lubricated, and you'll kill your dust when you sand with this. Again, Brad Evans uses it all the time. He thinks this stuff is really great.
Don't you also kill your options of finishing then, if you use that oil?
When you put a waxy surface on for sanding purpose, whether it's that, Johnson paste wax, here's some beeswax. I'm leading up to your answer. You ever used shoe polish? Neutral shoe polish is just wax. If you want to put color on, you can use black, brown, green, or blue, whatever, but this is a sanding. So once you wax the surface and you sand it with the wax through your grits, you will have created a surface that looks much different because you start filling pores in with the wax, and that causes it to darken or appear to darken. It's going to cause it to be more indicative of what the wood color, tone, tint actually is. Now, you prevented at this point from doing some finishing techniques. Because it's wax, you have to put something on after that that has a solvent in it. So your Watco, Minwax, White on Poly, all these will work fine. They work fine because they have a lot of volatile organics in it, and they'll dissolve the wax, penetrate through, and give you a nice finish. You can't put a lacquer on it. You can't put, well, you could put a shellac on, but generally shellac is either sprayed or put on fairly-like coats. It doesn't have enough solvent effect to take the wax away. You could do it with see, it's alcohol-based, it would do it. But the point is you need an oil-type finish. Lacquer won't do it. You just can't do a spray on top of that. Unless you go in there with a solvent and clean it all off. And that's problematic, that you can actually get it back out of all the pores. So it's the same thing if I'm making boxes. When I used to teach box making and the flat woodworking, you want to get this box joint at the corner done without getting wax or glue all over everything. What you do is wax this surface, glue it together. The glue seeps out, sits on the surface here, does not soak into the wood. And I can chip it off with my fingernail after it dries. And then I'm fixed with having to do an oil finish on to get rid of the wax that I put on.
Does it load up your sandpaper?
Oh, yeah. Oh, yeah. It does load up your sandpaper. So you have a lot of it. But nothing's more difficult than messing around with sawdust and that sanding dust. And it just messes up your garage or your shop.
What I find is the Abernet works really well, and then I can come back and hit it with denatured alcohol, and that will clean out, I do a lot of shellac first. It'll clean out the shellac, it'll clean out wax, and some air, and stuff lasts a long time.
Quick, and I'm going to end here with this. You know what these guys are? Everybody see these things? Inertial sanders. If you don't have one, I'm surprised. I have several different ones. But it's not used flat. It's used at an angle because when this bowl spins, for those of you who've never done this, on the outside, I'm going to hit it with the edge, which causes the device to spin also. That way I'm getting a randomized scratch pattern as I go across. And that's the point of this whole idea, is to get that randomized pattern. If I lay it flat, I'm going to get sanding like I'm holding the sandpaper in my hand. It doesn't work. The other thing that's important if you have one of these things is to go into the store and buy an intermediate pad of some sort. This is plastic, these hooks, and as the sandpaper gets hot, the plastic begins to fail and you lose your device. So I put an intermediate in between here, and there's soft ones, medium ones, and hard ones, and we've got them in the store of all different grits and grades and sizes. So when I trash this thing, I just throw it away. My device is still in great shape. And when they start flying off, and they won't stay there and start flying off, that means that you've lost all your little hooks on you. They're plastic hooks. Heat also tells you two things. Number one, it's gone. Number two, you've been pushing too hard because you generated too much heat. The plastic has failed early. Ed?
Even when you're using the straight strip of sandpaper that you were demonstrating earlier, I put a foam pad behind there. It's the same thing as there.
It's even using with the strips, put a pad behind it, protects your hands and so on. There's the sanding gloves. There's a company called the Sanding Glove. They actually make sanding gloves. So both of them, yeah. A couple more questions, and then I'm going to let you go get some free will.
After I fix my surface with 80 grit, how long do you sand each successive? How do I know when I'm done with each grit?
I will sand with my coarsest grits until all the imperfections of the surface are blended out. 80 grit, I'm going to take out the hills and valleys of my tool marks. I'm going to have some ridges because the tools are going to always leave some kind of ridge. I go to 120 until I've taken out all the 80 grit marks. I go to 180 until I've taken out all the 120 grit marks. Now, how do I know that? Brad uses a reciprocal sander, and I just laid mine down. Here it is. And he'll sand this direction at 80 grit, and he'll sand this direction at 120 grit. So the marks at 80 grit are going one direction. The 120 grit marks are going the opposite direction. I can tell if there's still 80 grit marks left. Yeah.
Another thing Brad does is reverse his lathe forever.
Same idea. Yeah, it causes the sanding swirls to go the opposite direction. The goal you're shooting for is no swirls visible when you're ready to put a finish on. And my experience with Woodturners, I've created this beautiful project, and I'm going to throw a quick finish on it and go show it to my friends. My feeling is that sanding and surface completion is almost as much work as the turning itself can be. If you want a good piece, spend the extra time at the very end to make it look that way. Nothing's worse than seeing a really nice shape brought into bright illuminated light and the sanding swirls are all visible in there, or the tear out is still there someplace. So you take it outside in the bright sunlight and examine it carefully. And if you can see it, go back to work, do some more sanding. Okay, I hope some of these questions or some of these points have been interesting, and maybe there was a point or two in there that you picked up that you didn't know. I hope so. So this is kind of like an extended class. So I thank you for allowing me to come back in January, as I have in the last years, and hope I'm still around to do it next year.
So if everybody could help